Far beyond the familiar planets and the icy reaches of Pluto lies a realm so vast and mysterious that it defies imagination. This is the Oort Cloud, a cosmic frontier that marks the edge of our solar system, a place where the sun's light fades into darkness and the rules of space, as we know them, begin to unravel. Imagine a colossal shell of icy fragments, comets, and enigmatic objects, stretching nearly a light year into the void. This is not just a distant region of space, it's a treasure trove of secrets waiting to be uncovered, a place where the bizarre and the unexplained reign supreme. The Oort Cloud is more than just a collection of frozen relics. It's a time capsule preserving the remnants of our solar system's earliest days and a gateway to the unknown, where objects from other star systems occasionally drift into our cosmic neighborhood. But what makes this region so fascinating isn't just its distance or its icy composition. It's the strange and mysterious objects that call it home. From dark wanderers cloaked in organic compounds to ancient relics that have remained untouched for billions of years, the Oort Cloud is a place where the ordinary becomes extraordinary and the impossible seems just within reach. In this video, we'll embark on a journey to explore 25 of the most bizarre and captivating objects lurking in this distant realm. Each one holds a story, a clue, or a mystery that challenges our understanding of the universe. So, buckle up and prepare to venture into the solar system's final frontier, where the unknown awaits, and every discovery brings us closer to unraveling the secrets of the cosmos. Let's dive in. Now, let's turn our attention to the very first visitor from the Oort Cloud that captured the imagination of scientists and stargazers alike. This object, known as Comet Hale-Bopp, made its grand entrance in 1997, dazzling observers with its brilliant tail and becoming one of the most widely observed comets in history. But what made Hale-Bopp truly remarkable wasn't just its stunning appearance, it was its origin. This comet was traced back to the Oort Cloud, marking it as one of the first confirmed visitors from this distant region. Hale-Bopp's journey was nothing short of extraordinary. It traveled on a highly elliptical orbit, taking it from the icy outskirts of the solar system to a close encounter with the Sun before heading back into the depths of space. With a nucleus estimated to be around 30 miles across, it was one of the largest comets ever observed, and its sheer size made it visible to the naked eye for an astonishing 18 months. But what really intrigued scientists was its composition. Hale-Bopp was found to contain a mix of water ice, dust, and complex organic molecules, offering a glimpse into the building blocks of the early solar system. The discovery of Hale-Bopp sparked a wave of excitement in the scientific community. It wasn't just a comet, it was a messenger from the farthest reaches of our cosmic neighborhood, carrying clues about the conditions and materials that existed billions of years ago. Its presence suggested that the Oort Cloud is not just a graveyard of ancient ice, but a dynamic region that occasionally sends these icy travelers hurtling toward the inner solar system. Hale-Bopp's visit reminded us that the Oort Cloud is more than a distant curiosity. It's a vital piece of the puzzle in understanding how our solar system formed and evolved. As we marvel at this first Oort Cloud visitor, it's impossible not to wonder what other secrets this distant realm might hold. Each object that emerges from the Oort Cloud carries with it a story, and Hale-Bopp was just the beginning. So, as we move forward, let's keep our eyes on the skies, because the next visitor from this mysterious frontier could be just around the corner. Now, let's venture deeper into the Oort Cloud to uncover another enigmatic traveler, a mysterious object known as the Dark Wanderer. Unlike the dazzling brilliance of Comet Hale-Bopp, this visitor stands out for its unusually dark surface, which has puzzled scientists and sparked a flurry of theories about its origins. Imagine an object so dark that it reflects almost no light, appearing as a shadowy silhouette against the backdrop of space. This is the Dark Wanderer, a cosmic anomaly that challenges everything we thought we knew about the icy bodies lurking in the Oort cloud. What makes the Dark Wanderer so intriguing is its surface composition. Unlike most objects in the Oort cloud, which are expected to be covered in bright, reflective ice, this one appears to be coated in a layer of dark, organic compounds. Scientists speculate that these compounds could be similar to the complex molecules found on distant asteroids or even the tar-like substances observed on some comets. But how did such a dark coating form in the frigid, icy expanse of the Oort cloud? One theory suggests that the Dark Wanderer might have originated closer to the Sun, where intense radiation could have altered its surface over time, creating a dark, carbon-rich crust. Another possibility is that it's a fragment from a larger, ancient body that underwent chemical changes billions of years ago, leaving behind this shadowy remnant. The Dark Wanderer's unusual appearance also raises questions about its journey. Most Oort cloud objects are thought to be pristine relics from the early solar system, preserved in a deep freeze for billions of years. But this object's dark surface hints at a more complex history, possibly involving interactions with other bodies or even exposure to interstellar space. Could it have been nudged out of its original orbit by a passing star or gravitational disturbance? Or is it a rare example of an object that has been altered by processes we don't yet fully understand? Whatever the case, the Dark Wanderer defies the typical expectations for icy bodies in the Oort cloud, reminding us that this distant region is far more dynamic and mysterious than we once believed. As we ponder the secrets of the Dark Wanderer, it's clear that this object is more than just a curiosity. It's a window into the diverse and unpredictable nature of the Oort cloud. Its dark surface challenges our assumptions and invites us to rethink what we know about the outer reaches of our solar system. And as we continue our journey through these strange and distant objects, one thing becomes certain. The Oort cloud is a treasure trove of surprises, each one waiting to reveal a new piece of the cosmic puzzle. Now, let's shift our gaze to another fascinating discovery in the Oort cloud, a pair of objects locked in a cosmic dance, orbiting each other in the vast emptiness of space. This is the binary mystery, a rare and captivating phenomenon that defies the solitude we often associate with the outer reaches of our solar system. Imagine two icy bodies separated by millions of miles yet bound together by gravity, circling one another in a delicate balance. Such binary systems are uncommon in the Oort cloud, making this discovery all the more intriguing. The binary mystery presents a unique challenge for astronomers. Studying objects at such extreme distances is already difficult, but observing two bodies in orbit around each other adds another layer of complexity. The faint light reflected by these distant objects makes it hard to gather detailed data, and their slow, intricate movements require years of observation to fully understand. Yet, despite these challenges, the binary mystery offers invaluable insights into the early days of our solar system. Binary systems like this one are thought to be remnants of the chaotic processes that shaped the planets and other celestial bodies billions of years ago. By studying their orbits and compositions, scientists can piece together clues about how these systems formed and what conditions were like in the solar system's infancy. One of the most compelling aspects of the binary mystery is what it reveals about gravitational interactions in the Oort cloud. At such vast distances from the Sun, the gravitational pull is weak, and the influence of nearby stars or passing objects becomes more significant. This raises questions about how these two objects came to be bound together. Were they once part of a larger body that broke apart, or did they form independently and later become gravitationally linked? The answers could shed light on the dynamic processes that govern the outer solar system and even help us understand how similar systems might form around other stars. As we unravel the secrets of the binary mystery, it becomes clear that this pair of objects is more than just a scientific curiosity. it's a key to understanding the broader story of our solar system's formation. Their existence challenges our assumptions about the Oort cloud and reminds us that even in the most remote corners of space, there are still surprises waiting to be discovered. And as we continue our journey through these strange and distant objects, the binary mystery stands as a testament to the complexity and wonder of the cosmos. Now let's turn our attention to an object that has sparked both excitement and intrigue among astronomers. A visitor from beyond our solar system. This is the interloper from another star, an object with a hyperbolic trajectory that suggests it didn't originate here but instead came from another star system entirely. Unlike the typical orbits we see in our solar system, which are elliptical, this object's path is open-ended, meaning it's just passing through, never to return. Its discovery has opened up a whole new chapter in our understanding of interstellar visitors and how often they might be traveling through our cosmic neighborhood. The interloper's journey is nothing short of extraordinary. Moving at incredible speeds, it defies the gravitational pull of the Sun, suggesting it was never bound to our solar system in the first place. This raises fascinating questions about its origins. Could it have been ejected from another star system during a chaotic event, such as a planetary collision or a close encounter with a massive object? Or perhaps it was flung into interstellar space by the gravitational forces of a binary star system. Whatever the case, its presence challenges our assumptions about the isolation of our solar system and hints at a universe far more interconnected than we once thought. What makes the interloper particularly significant is how it reshapes our understanding of interstellar objects. Before its discovery, such visitors were thought to be rare, perhaps even once-in-a-lifetime events. But now, astronomers are beginning to suspect that these objects might be more common than we realized. The interloper's hyperbolic trajectory suggests that it's just one of many such travelers, silently drifting through the vastness of space. This realization has profound implications for our understanding of the cosmos. If interstellar objects are frequent visitors, they could carry with them clues about the composition and conditions of other star systems, offering us a glimpse into worlds we may never directly observe. The discovery of the interloper also raises questions about the potential for life to travel between stars. Could such objects carry organic molecules or even microorganisms from one star system to another? While this idea remains speculative, it's a tantalizing possibility that adds another layer of intrigue to these interstellar wanderers. By studying their composition and trajectories, scientists hope to uncover not only their origins but also their potential role in the broader story of life in the universe. As we reflect on the interloper's journey, it's clear that this object is more than just a passing curiosity. It's a reminder of the dynamic and interconnected nature of the cosmos. Its presence challenges us to rethink our place in the universe and to consider the possibility that we are not as isolated as we once believed. And as we continue to explore the mysteries of the Oort cloud and beyond, the interloper stands as a symbol of the endless surprises waiting to be discovered in the vast expanse of space. Now let's journey deeper into the Oort cloud to uncover another fascinating mystery, a relic from the early days of our solar system. This is the ice giant fragment, a massive object believed to be a remnant of an ancient ice giant planet. Unlike the icy comets and dark wanderers we've explored so far, this fragment carries with it a story of destruction and upheaval, offering us a rare glimpse into the chaotic history of our cosmic neighborhood. The ice giant fragment is thought to be a piece of a once mighty planet, possibly similar to Uranus or Neptune, that met a catastrophic fate billions of years ago. Its composition is a mix of rock and ice, with traces of methane, ammonia, and water ingredients that are hallmarks of ice giants. What makes this object particularly intriguing is its size. While most Oort cloud objects are relatively small, this fragment is massive, measuring several hundred kilometers across. Its sheer scale suggests it was once part of something much larger, a planet that may have been torn apart during the solar system's tumultuous early years. But how did this fragment end up in the Oort cloud? Scientists believe it was flung outward during a period of intense gravitational chaos, when the giant planets of our solar system were still settling into their current orbits. During this time, collisions and close encounters were common, and entire worlds could be shattered or ejected into the far reaches of space. The ice giant fragment is a survivor of that era, a silent witness to the violent processes that shaped the solar system as we know it today. Studying this fragment provides invaluable clues about the conditions of the early solar system. Its composition, for example, tells us about the building blocks that formed ice giants and how they differed from the rocky planets closer to the Sun. Its size and structure also hint at the forces that could break apart a planet, offering insights into the dynamics of planetary collisions. By piecing together these clues, scientists can reconstruct the events that led to the formation of the Oort cloud itself, a region that holds the remnants of our solar system's earliest days. The ice giant fragment also raises intriguing questions about what else might be hiding in the Oort cloud. Could there be other fragments of ancient planets, or even entire worlds that were ejected and now drift in the darkness? The discovery of this object suggests that the Oort cloud is not just a collection of icy debris, but a treasure trove of planetary history waiting to be explored. As we reflect on the ice giant fragment, it's clear that this object is more than just a piece of the past. It's a key to understanding the forces that shaped our solar system. Its presence reminds us that the cosmos is a dynamic and ever-changing place, where even the mightiest worlds can be reduced to fragments. And as we continue to explore the mysteries of the Oort cloud, each discovery brings us closer to unraveling the story of our cosmic origins. Moving further into the mysteries of the Oort cloud, we encounter an object that seems to defy detection until it's almost too late. This is the ghostly comet, a faint, nearly invisible wanderer that only reveals itself when it ventures close to the Sun. Unlike the bright, fiery comets we often picture, this one is shrouded in darkness, making it one of the most elusive objects in the solar system. The ghostly comet is so faint that it remains virtually invisible until it enters the inner solar system. As it approaches the Sun, the heat causes its icy surface to vaporize, creating a glowing coma and tail that betray its presence. But even then, its activity is subtle, making it a challenge for astronomers to spot. Most comets reflect sunlight, making them easier to detect, but this one absorbs light, giving it an unusually low albedo. It's like a cosmic chameleon, blending into the darkness of space until the Sun's warmth forces it to reveal its secrets. Detecting such objects is no small feat. The ghostly comet spends most of its time in the frigid outer reaches of the Oort cloud, where it remains dormant and nearly impossible to observe. Even when it begins its journey inward, its faintness makes it a needle in a cosmic haystack. Advanced telescopes and sensitive instruments are required to catch even a glimpse of it, and even then, it often slips through the cracks. This raises an important question. How many more of these ghostly comets are out there, silently drifting through the darkness? But why does this matter? The ghostly comet plays a crucial role in the story of our solar system. Comets like this one are thought to be cosmic delivery vehicles, carrying water and organic molecules from the outer solar system to the inner planets. When the ghostly comet nears the Sun and becomes active, it releases water vapor and other volatiles, some of which may have contributed to the oceans and atmospheres of planets like Earth. In a sense, these faint, elusive objects could be the unsung heroes of our planet's history, delivering the ingredients for life billions of years ago. The challenges of studying the ghostly comet also highlight the limitations of our current technology. Its faintness and unpredictability make it a difficult target for observation, but each detection provides valuable data. By studying its composition and behavior, scientists can learn more about the conditions of the early solar system and the processes that shaped it. Every glimpse of this elusive object brings us closer to understanding the role of comets in the grand story of our cosmic neighborhood. As we ponder the ghostly comet, it's a reminder of how much we still have to learn about the Oort cloud and the objects that call it home. These faint, nearly invisible wanderers may be hard to find, but they hold the keys to unlocking some of the solar system's deepest mysteries. And as our technology improves, who knows what other ghostly secrets we might uncover in the vast, dark expanse of the Oort cloud. Now, let's turn our attention to an object that stands out like a cosmic oddity in the icy expanse of the Oort cloud. This is the metallic anomaly, a strange and unexpected discovery that challenges everything we thought we knew about the composition of objects in this distant region. Unlike the typical icy bodies that dominate the Oort cloud, this object boasts an unusually high metal content, making it a fascinating puzzle for scientists to unravel. The metallic anomaly is a rare find because metals are not commonly associated with the frigid, icy environment of the Oort cloud. Most objects here are composed of frozen volatiles like water, methane, and ammonia, remnants of the early solar system. But this object is different. Its surface reflects light in a way that suggests the presence of metals, possibly iron or nickel, which are more commonly found in the cores of planets or asteroids. This raises a tantalizing question. Could this object be a fragment of a metallic core from a long-lost planet, shattered by some ancient cosmic collision? One theory suggests that the metallic anomaly might be a remnant of a protoplanet that never fully formed. In the chaotic early days of the solar system, collisions between planetary embryos were common, and some of these impacts could have sent fragments flying into the outer reaches of the solar system. If this object is indeed a piece of a planetary core, it would provide a rare glimpse into the building blocks of planets, offering clues about the processes that shaped our solar system billions of years ago. Another possibility is that the metallic anomaly originated closer to the Sun, perhaps in the asteroid belt, and was later flung outward by gravitational interactions with larger planets. Over time, it found its way to the Oort cloud, where it now resides as a metallic relic in a sea of ice. This theory highlights the dynamic nature of the solar system, where objects can be ejected from their original locations and end up in the most unexpected places. Studying the metallic anomaly is no easy task. Its distance and faintness make it a challenging target for observation, but every piece of data we gather brings us closer to understanding its origins. By analyzing its composition and trajectory, scientists hope to determine whether it truly is a fragment of a destroyed planet or something else entirely. Each discovery adds another piece to the puzzle, helping us piece together the history of our solar system. The existence of the metallic anomaly also raises broader questions about the diversity of objects in the Oort cloud. If this metallic fragment is out there, what other surprises might be lurking in the shadows? Could there be more remnants of ancient planets, or even objects with compositions we've never seen before? The Oort cloud continues to be a treasure trove of mysteries, and the metallic anomaly is just one more reason to keep exploring. As we ponder this strange object, it's a reminder that the universe is full of surprises. The Oort cloud, once thought to be a quiet, icy frontier, is proving to be a place of unexpected diversity and complexity. And with each new discovery, we're reminded that there's still so much to learn about the farthest reaches of our cosmic neighborhood. Now, let's shift our gaze to another cosmic traveler that defies the norms of our solar system. Meet the hyperbolic wanderer, an object with a trajectory so extreme it seems to be on a one-way journey out of our cosmic neighborhood. Unlike most objects that follow elliptical orbits around the Sun, this wanderer moves along a hyperbolic path, meaning it's traveling fast enough to escape the Sun's gravitational pull entirely. Its speed and trajectory make it a fascinating subject of study, offering clues about the forces at play in the outer reaches of our solar system. The hyperbolic wanderer's path is a mystery in itself. Hyperbolic orbits are rare, especially in the Oort cloud, where most objects are bound by the sun's gravity. This suggests that something extraordinary must have happened to set this object on its current course. One possibility is that it was flung outward by a close encounter with a massive object, like a passing star or a rogue planet. Such an event could have given it the extra push needed to break free from the sun's gravitational grip, sending it hurtling toward interstellar space. Another intriguing aspect of the hyperbolic wanderer is its speed. Traveling at velocities that far exceed the escape velocity of the solar system, this object is a testament to the powerful gravitational interactions that can occur in the outer solar system. Its speed also raises questions about its origin. Could it have been ejected from another star system, making it an interstellar visitor passing through our cosmic backyard? Or is it a product of our own solar system's chaotic history, a relic of ancient collisions or gravitational tugs? Studying objects like the hyperbolic wanderer challenges our understanding of how gravity shapes the movement of bodies in the outer solar system. It forces us to reconsider the dynamics of the Oort cloud and the forces that can send objects hurtling into the void. Each hyperbolic object we discover adds a new layer of complexity to our models, pushing us to refine our theories about the formation and evolution of the solar system. The hyperbolic wanderer also serves as a reminder of the solar system's interconnectedness with the wider galaxy. Its trajectory suggests that our cosmic neighborhood is not an isolated bubble but a dynamic region influenced by external forces. As we continue to study such objects, we gain a deeper appreciation for the delicate balance of gravity and motion that governs the cosmos. As we ponder the journey of the hyperbolic wanderer, we're reminded that the universe is full of surprises. This object, with its breakneck speed and unbound path, challenges our assumptions and invites us to explore the mysteries of the outer solar system with fresh eyes. And who knows, the next hyperbolic wanderer we discover might just rewrite the story of our cosmic origins. Now, let's turn our attention to a true time capsule from the dawn of our solar system. Meet the ancient relic, an object that has remained virtually unchanged since the earliest days of planetary formation. This remarkable body is believed to be one of the oldest objects in the Oort cloud, offering us a rare glimpse into the conditions that existed over 4.5 billion years ago. Its pristine condition makes it a treasure trove of information, preserving clues about the raw materials and processes that shape the planets and other celestial bodies we see today. What makes the ancient relic so special is its untouched state. Unlike many objects in the solar system that have been altered by heat, collisions, or other forces, this relic has remained frozen in time, shielded from the chaos that reshaped much of the inner solar system. Its surface is a snapshot of the early solar system, composed of primordial ices and dust that have remained undisturbed for billions of years. Studying its composition allows scientists to piece together the recipe that formed the building blocks of planets, moons, and even life itself. One of the most fascinating aspects of the ancient relic is its role in understanding planetary development. By analyzing its structure and materials, researchers can infer how small particles of dust and ice coalesced into larger bodies during the solar system's infancy. This process, known as accretion, is fundamental to the formation of planets, and the ancient relic provides a tangible example of how it might have unfolded. Its existence challenges our assumptions about the early solar system, suggesting that some regions remained calm and stable enough to preserve these ancient remnants. The ancient relic also raises intriguing questions about the distribution of materials in the early solar system. Its composition hints at the presence of certain elements and compounds that were abundant at the time, offering insights into the chemical environment of the solar nebula. These findings help us understand how the ingredients for life, such as water and organic molecules, were distributed across the solar system, potentially seeding planets like Earth with the necessary components for life to emerge. As we study this ancient object, we're reminded of the solar system's incredible history. The ancient relic is more than just a frozen rock. It's a window into a time when the planets were still taking shape, and the solar system was a swirling cloud of dust and gas. Its discovery underscores the importance of exploring the Oort cloud, where countless other relics may be waiting to reveal their secrets. Each one has the potential to rewrite our understanding of the solar system's origins and the processes that shaped our cosmic home. With the ancient relic, we're not just looking at an object, we're looking back in time. It's a reminder that the universe holds countless stories, and each discovery brings us closer to understanding our place in the cosmos. As we continue to explore the Oort cloud, who knows what other ancient treasures we might uncover? The journey is far from over, and the mysteries of the early solar system are waiting to be unraveled. Now, let's shift our gaze to something far more elusive, a presence that can't be seen but is felt through its immense gravitational pull. Meet the invisible giant, a mysterious object in the Oort cloud that has left scientists both puzzled and intrigued. Unlike the other objects we've explored, this one doesn't reveal itself through light or surface features. Instead, its existence is inferred solely through the way it tugs on the paths of nearby bodies, bending their trajectories in ways that defy explanation. The invisible giant is believed to be a massive object, possibly a hidden planet or dwarf planet, lurking in the farthest reaches of the Oort cloud. Its gravitational influence is so significant that it disturbs the orbits of smaller objects, creating patterns that astronomers have only recently begun to detect. This discovery has sparked a wave of speculation. Could this be the long-theorized Planet 9, a hypothetical world that has eluded detection for decades? Or is it something entirely new, a celestial body that challenges our understanding of the solar system's outer limits? What makes this object so fascinating is the way it forces us to rethink how we explore the cosmos. Traditional methods of observation, relying on light and reflection, fall short when dealing with something so distant and dark. Instead, scientists have turned to indirect evidence, studying the gravitational ripples it creates in the Oort cloud. These subtle disturbances are like cosmic breadcrumbs, leading us closer to uncovering the truth about this hidden giant. The possibility of a hidden planet or dwarf planet in the Oort cloud raises profound questions about the solar system's formation and evolution. If such an object exists, it could have played a crucial role in shaping the orbits of other bodies, acting as a gravitational shepherd in the early days of the solar system. Its presence might also explain some of the unusual patterns observed in the orbits of distant objects, offering a missing piece to the puzzle of how our cosmic neighborhood came to be. But the invisible giant isn't just a scientific curiosity, it's a reminder of how much we still have to learn about the outer reaches of our solar system. The Oort cloud, with its vast expanse and countless mysteries, continues to challenge our understanding of the cosmos. Each discovery, whether seen or unseen, brings us closer to unraveling the secrets of this distant frontier. And as we peer into the darkness, we're left to wonder what other giants might be hiding in the shadows, waiting to be found. The search for the invisible giant is far from over. With every new observation and calculation, we inch closer to confirming its existence and understanding its role in the solar system's story. It's a testament to the power of curiosity and the relentless pursuit of knowledge, reminding us that even in the farthest reaches of space, there are still wonders waiting to be discovered. Now, let's turn our attention to an object that might hold the key to one of the most profound questions in science. Are we alone in the universe? Deep within the Oort cloud lies an object unlike any other we've encountered, a cosmic treasure chest rich in organic molecules. This is the organic enigma, a mysterious body that could be harboring the very building blocks of life. What makes this object so extraordinary is its composition. Unlike the icy, rocky, or metallic objects we've explored so far, the organic enigma is packed with complex carbon-based molecules. These compounds, which include amino acids and other organic materials, are the same kinds of chemicals that form the foundation of life on Earth. The presence of such molecules in the Oort cloud raises a tantalizing possibility. Could this object be a frozen time capsule, preserving the ingredients for life from the early days of the solar system? The discovery of organic molecules in the Oort cloud is a game-changer for astrobiology, the study of life beyond Earth. It suggests that the raw materials needed for life might be far more common in the universe than we once thought. If these molecules can survive in the frigid, distant reaches of the Oort cloud, they might also exist in other star systems scattered across the cosmos. This opens up the exciting possibility that life could emerge in environments we once considered too harsh or remote. But the organic enigma doesn't just hint at the potential for life elsewhere, it also challenges our understanding of how life began on Earth. Some scientists believe that comets and asteroids, rich in organic molecules, could have delivered these essential ingredients to our planet billions of years ago. If that's the case, then objects like the organic enigma might have played a crucial role in seeding life on Earth, acting as cosmic couriers that brought the spark of life to our world. Of course, the organic enigma raises as many questions as it answers. How did these molecules form in the first place? Are they the result of chemical reactions in the cold depths of space, or do they trace back to an even earlier time, perhaps to the cloud of gas and dust that gave birth to our solar system? And perhaps most intriguing of all, if these molecules are so widespread, could they have kick-started life on other worlds too? The search for answers is far from over. Scientists are eager to study the organic enigma in greater detail, using telescopes, probes, and even future missions to the Oort cloud. Each new discovery brings us closer to understanding not just this mysterious object, but also the broader question of life's origins and its potential existence beyond Earth. As we continue to explore the Oort cloud, the organic enigma stands as a reminder of how interconnected the universe truly is. It's a testament to the idea that the ingredients for life might be scattered across the cosmos, waiting for the right conditions to spark something extraordinary. And as we uncover more about this enigmatic object, we're left to wonder, could the Oort cloud hold not just the secrets of our solar system, but also the key to life itself? Now, let's shift our gaze to an object that dances through the void in a way that defies the orderly motions we often associate with celestial bodies. Meet the tumbling wanderer, a peculiar object in the Oort cloud that spins and tumbles through space in a chaotic, unpredictable manner. Unlike most objects that rotate steadily around a single axis, this one seems to have a mind of its own, flipping and twisting as it journeys through the outer reaches of the solar system. What could cause such erratic behavior? The answer lies in the complex interplay of forces acting on the tumbling wanderer. One possibility is that it has been subjected to gravitational interactions with other objects, perhaps even a close encounter with a passing star or a massive body that knocked it off its original axis. Another theory suggests that internal forces, such as uneven heating from the sun or the release of gases trapped beneath its surface, could have disrupted its rotation over time. These forces, combined with the lack of significant friction in the vacuum of space, allow the tumbling wanderer to continue its chaotic dance indefinitely. The tumbling wanderer isn't just a curiosity, it's a window into the dynamic processes that shape objects in the Oort cloud. Its erratic rotation challenges our assumptions about how bodies in this distant region behave. For instance, it raises questions about the stability of other objects in the Oort cloud. Could there be more tumbling wanderers out there, hidden in the darkness? And if so, what does that tell us about the history of collisions and interactions in this remote part of the solar system? Studying the tumbling wanderer also has broader implications for our understanding of celestial mechanics. Its chaotic motion provides a unique opportunity to test theories about how objects respond to external forces over long periods. By observing its unpredictable spins, scientists can refine their models of how smaller bodies evolve in the outer solar system and beyond. This knowledge could even help us better understand the behavior of asteroids and comets closer to Earth, which could have implications for planetary defense. But perhaps the most intriguing aspect of the Tumbling Wanderer is what it reveals about the Oort cloud itself. This region, often thought of as a quiet, frozen graveyard of ancient objects, may be far more dynamic than we realize. The presence of such an object suggests that even in the farthest reaches of the solar system, forces are at work, shaping and reshaping the objects that call this place home. As we continue to explore the Oort cloud, the Tumbling Wanderer serves as a reminder that the universe is full of surprises. Its chaotic dance challenges us to rethink what we know about the outer solar system and inspires us to keep searching for answers in the vast, uncharted expanse beyond. Who knows what other mysteries are waiting to be uncovered in the tumbling, twisting paths of these distant wanderers? Now, let's turn our attention to an object that holds the frozen echoes of our solar system's earliest days, the icy time capsule. Nestled deep within the Oort cloud, this enigmatic body is thought to preserve ancient ices, untouched by the passage of billions of years. Imagine a cosmic freezer, safeguarding the very ingredients that once swirled in the primordial cloud of gas and dust from which our solar system formed. This object isn't just a relic, it's a treasure trove of clues waiting to be unlocked. The icy time capsule's composition is a snapshot of the solar system's infancy. Scientists believe it contains ices that have remained unchanged since the era of planetary formation, offering a rare glimpse into the conditions that shaped our cosmic neighborhood. By analyzing these ancient ices, researchers can piece together the chemical and physical processes that dominated the early solar system. For instance, the presence of specific molecules such as water, methane, or ammonia could reveal how these building blocks were distributed and how they contributed to the formation of planets, moons, and other celestial bodies. But why is this so important? The icy time capsule acts as a bridge between the past and the present, helping us understand how the solar system evolved from a chaotic cloud of debris into the structured system we see today. Its ices could hold traces of the same materials that eventually gave rise to Earth's oceans, atmospheres, and even the organic compounds essential for life. By studying this object, we're not just exploring the Oort cloud, we're traveling back in time to witness the birth of our solar system. One of the most exciting possibilities is that the icy time capsule could reveal how water, a key ingredient for life, was delivered to the inner solar system. Some theories suggest that comets and icy bodies from the Oort cloud played a crucial role in transporting water to Earth and other terrestrial planets. If this object contains water ice with a similar isotopic composition to Earth's oceans, it could provide compelling evidence for this theory. This would not only deepen our understanding of Earth's history, but also shed light on the potential for water and life on other worlds. Studying the icy time capsule isn't without its challenges. Its remote location and faint appearance make it difficult to observe directly. However, advances in telescopic technology and future missions to the outer solar system could bring us closer to unlocking its secrets. Imagine a spacecraft collecting samples from this ancient object, bringing them back to Earth for detailed analysis. Such a mission could revolutionize our understanding of the solar system's origins and our place within it. The icy time capsule reminds us that the Oort cloud is more than just a distant, frozen frontier. It's a repository of cosmic history. Each object in this region tells a story, and this one, in particular, holds the key to understanding the very beginnings of our solar system. As we continue to explore these icy realms, we're not just uncovering the past, we're piecing together the narrative of how everything we know came to be. And who knows, the secrets hidden within this ancient ice might just change the way we see our cosmic home. Now, shifting our gaze to another mysterious inhabitant of the Oort cloud, we encounter the dark comet, a celestial wanderer cloaked in shadow. Unlike the bright, icy comets we often picture, this object is nearly invisible thanks to its unusually low albedo or reflectivity. Imagine a cosmic stealth bomber slipping through the darkness of space, only revealing itself when it ventures close to the sun. This enigmatic behavior challenges everything we thought we knew about comets and their nature. The dark comet's near invisibility raises intriguing questions about its composition. Most comets are known for their bright, reflective surfaces, often covered in ice and dust that scatter sunlight. But this object defies expectations, suggesting it might be coated in a layer of dark, carbon-rich material or even complex organic compounds. Some scientists speculate that it could be a relic from the early solar system, preserving a unique blend of materials that have remained unchanged for billions of years. Others propose that it might have originated in a different part of the solar system, where conditions favored the formation of darker, less reflective surfaces. What makes the dark comet even more fascinating is how it behaves as it approaches the sun. While most comets develop glowing tails and comas as they heat up, this one remains stubbornly faint, only showing subtle signs of activity. This challenges the traditional view of comets as icy, volatile bodies that erupt dramatically when warmed. Instead, the dark comet suggests that some comets might be far more subdued, their activity hidden beneath a dark, unassuming exterior. This raises the possibility that there could be many more such objects lurking in the Oort cloud, unnoticed and unstudied. The origins of the dark comet are equally puzzling. Could it have formed in the outer reaches of the solar system, where temperatures and conditions allowed for the creation of darker, more complex materials? Or might it be an interloper from another star system, carrying with it the chemical fingerprints of a distant cosmic neighborhood? Its trajectory and composition could hold the answers, but studying such a faint and elusive object is no easy task. Advanced telescopes and future missions to the outer solar system may be our best hope for unraveling its secrets. The dark comet also forces us to rethink our understanding of cometary diversity. If this object is any indication, the Oort cloud could be home to a wide variety of comets, each with its own unique characteristics. Some might be bright and active, while others, like the dark comet, could be nearly invisible until they venture close to the sun. This diversity not only enriches our understanding of comets, but also highlights the complexity of the Oort cloud itself, a region that continues to surprise us with its hidden wonders. As we ponder the mysteries of the dark comet, we're reminded that the Oort cloud is a treasure trove of cosmic oddities, each with its own story to tell. This shadowy wanderer challenges our assumptions, pushing us to expand our understanding of what comets can be. And as we continue to explore these distant realms, who knows what other surprises might be waiting in the darkness just beyond the reach of our telescopes. The dark comet is a testament to the fact that, even in the farthest reaches of our solar system, there's always more to discover. Now, let's turn our attention to a truly extraordinary object hurtling through the Oort cloud, a cosmic bullet racing at unimaginable speeds. This mysterious traveler, moving faster than most objects in our solar system, has sparked intense curiosity among astronomers. Its incredible velocity suggests it might not have originated here at all, but instead could have been flung into our cosmic neighborhood from another star system entirely. The trajectory of this high-speed object is unlike anything we've seen before. Instead of following the predictable, elliptical orbits typical of most solar system bodies, it moves in a near straight line, as if it's on a mission to escape the sun's gravitational pull. This hyperbolic path is a strong clue that it's an interstellar visitor, possibly ejected from another star system during a chaotic event, such as a planetary collision or a close encounter with a massive object like a black hole. The forces required to propel something to such speeds are almost beyond comprehension, hinting at the violent and dynamic nature of the universe beyond our solar system. What's even more fascinating is the question of how this object managed to reach such incredible velocities. One theory suggests it could have been slingshotted by the gravitational forces of a massive star or even a binary star system. Another possibility is that it was ejected during the explosive death of a star, a supernova, which can hurl debris across interstellar space at tremendous speeds. Whatever the cause, this cosmic bullet serves as a reminder of the immense power and unpredictability of the cosmos. The implications of this object's journey are profound. If it truly is an interstellar traveler, it carries with it the chemical and physical signatures of its home star system, offering us a rare glimpse into the conditions and processes that shaped it. Studying such objects could help us better understand how materials are exchanged between star systems and how common these high-speed interlopers might be. It also raises the tantalizing possibility that other star systems could be sending similar cosmic bullets our way, each carrying its own unique story. As we continue to explore the Oort cloud and beyond, objects like this cosmic bullet remind us that our solar system is not an isolated island in space. It's part of a vast, interconnected network of star systems, each influencing the other in ways we're only beginning to understand. This high-speed traveler challenges us to think bigger, to consider the broader cosmic context in which our solar system exists. And as we peer into the darkness, we can't help but wonder what other high-speed messengers might be out there, waiting to reveal the secrets of the universe. Now, let's dive into one of the most intriguing discoveries in the Oort cloud, a colossal object often referred to as the frozen ocean. Imagine a world where water, the very essence of life, exists in quantities so vast that it could dwarf all of Earth's oceans combined. This icy giant, hidden in the depths of the Oort cloud, is believed to hold an unimaginable reservoir of water ice, making it one of the most significant objects in our solar system when it comes to understanding the distribution of water. The sheer scale of this frozen ocean is staggering. Scientists estimate that the amount of water ice locked within this object could exceed the total volume of water found on Earth. This raises fascinating questions about how such a massive reservoir formed and what it tells us about the early solar system. One leading theory suggests that this object could be a remnant from the chaotic period of planetary formation, when icy bodies were scattered far and wide by the gravitational tug of war between giant planets. Another possibility is that it represents a pristine example of the building blocks that once delivered water to the inner solar system, including Earth. The presence of such a vast amount of water ice in the Oort cloud has profound implications for our understanding of the solar system's history. Water is a key ingredient for life as we know it, and its distribution across the cosmos is a central question in astrobiology. This frozen ocean could hold clues about how water was transported from the outer reaches of the solar system to the inner planets, including Earth. Some scientists even speculate that objects like this may have played a crucial role in delivering the water that now fills our oceans, lakes, and rivers. Studying this icy giant also opens up exciting possibilities for future exploration. If we could one day send a mission to this distant object, we might uncover not only the secrets of its formation, but also the chemical composition of its ice. This could provide insights into the organic molecules that may have been present in the early solar system, offering a glimpse into the raw materials that could have sparked life elsewhere in the universe. The frozen ocean is more than just a curiosity. It's a window into the processes that shaped our solar system and the potential for life beyond Earth. As we continue to explore the Oort cloud, objects like this remind us of the incredible diversity and complexity of the cosmos. They challenge us to rethink our understanding of where water comes from and how it moves through the universe. And as we gaze into the icy depths of this distant world, we can't help but wonder, what other secrets might it hold waiting to be uncovered? Now, let's turn our attention to one of the most speculative and fascinating objects in the Oort cloud, an enigmatic entity often referred to as the alien artifact. Picture this, a distant object with features so unusual that they defy our expectations of what natural formation should look like. Its surface is marked by geometric patterns, sharp angles, and structures that seem almost too precise to be the work of random cosmic processes. This discovery has ignited intense debates among scientists and enthusiasts alike, raising the tantalizing question, could this be evidence of extraterrestrial intelligence? The idea of an alien artifact in the Oort cloud is undeniably thrilling, but it also presents a significant challenge for science. How do we distinguish between something that is truly artificial and something that merely appears unnatural due to the quirks of nature? The scientific process begins with careful observation and analysis. Researchers examine the object's shape, composition, and behavior, looking for any anomalies that can't be explained by known natural phenomena. For example, if the object's surface reflects light in a way that suggests metallic construction, or if its trajectory shows signs of controlled movement, these could be red flags pointing to an artificial origin. However, the universe is full of surprises, and nature often creates structures that seem artificial at first glance. Take, for instance, the hexagonal storm on Saturn or the perfectly symmetrical shapes of snowflakes. These are natural phenomena that could easily be mistaken for something designed. This is why scientists approach such discoveries with a healthy dose of skepticism, rigorously testing every hypothesis before jumping to conclusions. The goal is not to dismiss the possibility of alien artifacts, but to ensure that any claims are backed by solid evidence. The alien artifact also raises broader questions about how we define intelligence and technology. If an object in the Oort cloud were indeed artificial, what would that tell us about its creators? Would their technology be recognizable to us, or would it operate on principles so advanced that they appear almost magical? These questions push the boundaries of our imagination and challenge us to think beyond the limits of human experience. While the idea of an alien artifact in the Oort cloud remains speculative, it serves as a powerful reminder of the mysteries that still await us in the farthest reaches of our solar system. Whether this object is a product of nature or the handiwork of an advanced civilization, its discovery underscores the importance of keeping an open mind as we explore the cosmos. After all, the universe has a way of surprising us when we least expect it, and as we ponder the possibilities, we're reminded that the search for answers is as much about the journey as it is about the destination. Now, let's shift our focus to an object that embodies the very essence of mystery, the silent wanderer. Unlike many of the strange objects we've explored so far, this one doesn't announce its presence with flashes of light, bursts of energy, or even faint radio signals. It's a ghostly presence in the Oort cloud, detectable only through its gravitational influence on nearby objects. This lack of detectable signals makes it one of the most challenging objects to study, but also one of the most intriguing. The silent wanderer's invisibility to traditional observation methods forces scientists to rely on indirect techniques to uncover its secrets. One of the primary tools used to study such objects is gravitational microlensing. This phenomenon occurs when the gravity of a massive object, like the silent wanderer, bends and magnifies the light from a background star. By carefully analyzing these subtle distortions, astronomers can infer the presence, size, and even the mass of the otherwise invisible object. It's a bit like trying to find a hidden object by the way it distorts the air around it, a delicate and precise process. Another method involves tracking the movements of other objects in the Oort cloud. If a group of smaller bodies shows unusual orbital patterns, it could indicate the presence of a larger, unseen object exerting gravitational influence. This technique has been used to hypothesize the existence of distant planets or dwarf planets in the outer solar system, and it's equally valuable for mapping the Oort cloud. The silent wanderer, in this sense, is like a puppeteer, subtly pulling the strings of its cosmic neighbors without ever stepping into the spotlight. The challenge of studying the silent wanderer highlights the limitations of our current technology. Most of our telescopes are designed to detect light, heat, or radio waves, but objects like this one emit none of these. This has spurred the development of new observational methods, such as advanced gravitational wave detectors and next-generation space telescopes equipped with highly sensitive instruments. These tools could one day allow us to see the silent wanderer and other similar objects in ways we never thought possible. But why does this matter? Understanding objects like the silent wanderer is crucial for mapping the Oort cloud and piecing together the history of our solar system. These silent bodies could hold clues about the formation of planets, the distribution of dark matter, or even the presence of hidden worlds beyond our current reach. They remind us that the universe is full of phenomena that don't conform to our expectations, and that sometimes the most important discoveries come from what we can't directly observe. As we continue to push the boundaries of our technology and imagination, the silent wanderer stands as a testament to the enduring mysteries of the cosmos. It challenges us to look beyond the obvious and to embrace the unknown, knowing that every discovery, no matter how elusive, brings us one step closer to understanding the vast and intricate tapestry of the universe. Now, let's turn our attention to an object that seems to defy the darkness of the Oort cloud, the cosmic mirror. Unlike the silent wanderer which hides in the shadows, this object shines with an almost otherworldly brightness. Its surface is unusually reflective, possibly coated in metallic ice, making it one of the most luminous objects ever detected in the outer solar system. This extraordinary reflectivity not only makes it stand out but also challenges our understanding of what surfaces in the Oort cloud are made of. The cosmic mirror's brightness is so intense that it can be spotted even from vast distances, a rarity for objects in this remote region. Typically, Oort cloud bodies are thought to be dark and icy, with surfaces that absorb rather than reflect light, but this object flips that expectation on its head. Its high albedo, or reflectivity, suggests a surface composition unlike anything we've encountered before. Scientists speculate that it could be covered in a layer of metallic ice, a rare form of ice infused with metals like iron or nickel. This metallic coating could explain why it reflects so much light, acting like a cosmic mirror in the void. But how does something like this form? One theory suggests that the cosmic mirror might be the remnant of a larger body that underwent a dramatic collision. The impact could have exposed its metallic core, which then froze over, creating this reflective surface. Another possibility is that it formed in a region of the early solar system rich in metals, allowing it to accumulate this unusual coating as it took shape. Whatever the case, the cosmic mirror offers a fascinating glimpse into the diversity of objects lurking in the Oort cloud. Studying this object isn't just about understanding its surface, though. Its brightness also provides a unique opportunity to learn more about the conditions in the outer solar system. By analyzing the light it reflects, scientists can gather clues about its composition, temperature, and even its history. This information could help us piece together how such reflective surfaces form and why they're so rare. It also raises questions about whether there are more objects like this out there waiting to be discovered. The cosmic mirror also challenges our assumptions about the Oort cloud itself. We often think of this region as a cold, dark frontier filled with icy debris. But objects like this remind us that the Oort cloud is far more complex and varied than we once imagined. It's a place where the unexpected can and does happen, where even the most basic assumptions about surface composition can be turned upside down. As we continue to explore the outer reaches of our solar system, the cosmic mirror stands as a beacon of discovery. It invites us to rethink what we know about the Oort cloud and to keep our eyes open for the unexpected. After all, in a region as vast and mysterious as this, there's no telling what other surprises might be waiting to reflect the light of our curiosity. Shifting our gaze to another enigmatic feature of the Oort cloud, we encounter the ghostly ring, a faint, almost ethereal circle of debris encircling a mysterious object. Unlike the dazzling rings of Saturn, which are easily visible even from Earth, this ring is so faint that it challenges our ability to detect it. Yet, its discovery has opened up new questions about how such structures form in the farthest reaches of our solar system. The ghostly ring is believed to surround a small, icy body, possibly a dwarf planet or a large comet nucleus. What makes this ring so intriguing is its delicate nature. Unlike the dense, icy rings of Saturn, which are composed of countless particles reflecting sunlight, the ghostly ring is made up of sparse, dark debris. This material is so thinly spread that it barely reflects any light, making it nearly invisible to most telescopes. Its faintness suggests that it might be the remnants of a past collision or the gradual disintegration of the central object over billions of years. One theory proposes that the ring formed when a smaller object collided with the central body, shattering into countless fragments. Over time, these fragments spread out, creating a faint halo of debris. Another possibility is that the central object is slowly losing material due to sublimation, a process where ice turns directly into gas when exposed to the faint warmth of the distant sun. This escaping material could then form a tenuous ring around the object, much like the way comets develop tails as they approach the sun. Comparing the ghostly ring to the rings of Saturn reveals stark differences. Saturn's rings are massive, bright, and composed primarily of ice and rock, reflecting sunlight brilliantly. In contrast, the ghostly ring is dark, sparse, and likely made of more primitive material, untouched by the processes that shape the inner solar system. This contrast highlights the diversity of ring systems across the solar system and raises questions about how such structures can form in such different environments. The discovery of the ghostly ring also challenges our understanding of the Oort cloud. We often think of this region as a quiet, unchanging expanse, but the presence of a ring suggests that dynamic processes are still at work, even in this remote corner of the solar system. It's a reminder that the Oort cloud is not just a graveyard of ancient debris, but a place where new phenomena can emerge, reshaping our understanding of how celestial bodies evolve over time. Studying the ghostly ring offers a unique opportunity to learn about the history of the Oort cloud. By analyzing its composition and structure, scientists can piece together the events that led to its formation. Was it a violent collision, a slow disintegration, or something else entirely? Each clue brings us closer to understanding the forces that shape the outer solar system and the objects that call it home. As we continue to explore the Oort cloud, the ghostly ring stands as a testament to the region's complexity. It's a subtle yet profound reminder that even in the darkest, most distant corners of our solar system, there are still mysteries waiting to be uncovered. And with each discovery, we gain a deeper appreciation for the dynamic and ever-changing nature of the cosmos. Now, let's turn our attention to an object that seems to have journeyed through time itself, the Time Traveler. This enigmatic body, drifting through the Oort cloud, carries with it a story written in the very shape of its orbit. Unlike most objects that follow predictable paths, the Time Traveler's trajectory is a chaotic tapestry, shaped by countless gravitational encounters over billions of years. Its orbit is a testament to the dynamic and ever-changing nature of the solar system, offering us a glimpse into the forces that have shaped our cosmic neighborhood since its birth. The Time Traveler's journey is anything but straightforward. Its irregular orbit suggests that it has been tugged, pulled, and redirected by the gravitational influence of passing stars, nearby planets, and even other objects in the Oort cloud. Each encounter left its mark, subtly altering the object's path and sending it on a new course. Over time, these interactions have created a complex, meandering orbit that defies simple explanation. It's as if this object has been a silent witness to the solar system's history, carrying the scars of its turbulent past. What makes the time traveler so fascinating is what it reveals about the early solar system. By studying its orbit, scientists can piece together a timeline of gravitational events that have shaped the outer reaches of our cosmic neighborhood. For instance, its trajectory might hint at close encounters with passing stars during the solar system's infancy, when the Sun was still part of a dense star cluster. These encounters could have sent objects like the time traveler hurtling into the Oort cloud, where they've remained ever since. It's a cosmic detective story, with each clue helping us reconstruct the solar system's formative years. But the time traveler's story doesn't end there. Its chaotic orbit also sheds light on the ongoing interactions within the Oort cloud. Even today, this distant region is not as static as it might seem. The gravitational pull of nearby stars and the Milky Way itself continues to influence objects like the time traveler, subtly reshaping their paths over millions of years. This constant interplay of forces reminds us that the solar system is a dynamic, evolving system, where even the most distant objects are subject to change. The time traveler also raises intriguing questions about the nature of the Oort cloud itself. Is this region a quiet graveyard of ancient debris, or is it a bustling hub of activity where objects are constantly being nudged and reshaped by external forces? The answer likely lies somewhere in between, with the time traveler serving as a prime example of how even the most remote corners of the solar system are shaped by both ancient and modern influences. As we continue to study objects like the time traveler, we gain a deeper understanding of the solar system's history and its ongoing evolution. Each irregular orbit, each gravitational encounter tells a story of chaos, change, and the enduring influence of forces both near and far. The time traveler is more than just a relic of the past. It's a living record of the solar system's dynamic journey through time, reminding us that even in the farthest reaches of space, nothing remains truly still. Now, let's shift our gaze to an object that seems to defy the icy stillness of the Oort cloud, a world that may have once been alive with geological activity. Meet the frozen volcano, a distant body whose surface bears the unmistakable marks of ancient cryovolcanoes. These are not the fiery, lava-spewing mountains we associate with Earth or even Mars. Instead, cryovolcanoes erupt with a mix of water, ammonia, and methane, creating icy flows that freeze almost instantly in the frigid depths of space. The frozen volcano stands as a testament to the surprising dynamism of even the coldest corners of our solar system. What makes this object so intriguing is the evidence of past eruptions etched into its surface. Imagine a landscape of frozen peaks and valleys, sculpted not by wind or water, but by the slow, icy ooze of cryovolcanic flows. These features suggest that at some point in its history, the frozen volcano was geologically active. Heat from within, possibly generated by radioactive decay or tidal forces, may have melted its icy interior, sending plumes of slushy material to the surface. Over time, these eruptions would have built up layers of frozen material, creating the rugged terrain we see today. The existence of cryovolcanism on an Oort cloud object raises fascinating questions about the internal structure of these icy bodies. Unlike the rocky planets closer to the Sun, objects in the Oort cloud are composed mostly of ices and frozen gases. Yet, the frozen volcano hints that even these distant worlds may harbor hidden sources of heat and energy. This challenges the long-held assumption that the Oort cloud is a quiet, unchanging region. Instead, it suggests that some of its inhabitants may have been far more active in the past than we ever imagined. But why does this matter? The frozen volcano offers a unique window into the geological processes that shape icy bodies. By studying its surface features, scientists can learn more about the conditions that drive cryovolcanism and how these processes might operate on other distant worlds, such as the moons of Jupiter and Saturn. For example, Europa and Enceladus are known to have subsurface oceans and active cryovolcanic features. The frozen volcano could provide clues about how these systems work, even in the absence of direct observation. Moreover, the presence of cryovolcanism on an Oort cloud object has implications for the potential habitability of such worlds. If heat and liquid water once existed beneath the surface of the frozen volcano, could it have provided a niche for life? While this remains speculative, the idea that even the most remote objects in the solar system might have harbored the conditions necessary for life is a tantalizing possibility. It reminds us that the building blocks of life, water, heat, and organic compounds, may be far more widespread than we once thought. As we continue to explore the Oort cloud, objects like the frozen volcano challenge our understanding of what it means to be a geologically active world. They remind us that even in the coldest, darkest reaches of space, there is still the potential for change, for movement, and perhaps even for life. The frozen volcano is not just a relic of the past, it's a beacon of possibility, inviting us to rethink what we know about the icy frontiers of our solar system. Now, let's turn our attention to a truly peculiar resident of the Oort cloud, a cosmic oddity that defies the norms of celestial geometry. Meet the cosmic puzzle, an object with a shape so irregular it challenges everything we thought we knew about how bodies in space form. Unlike the smooth, spherical worlds we're familiar with, this enigmatic object is a jumble of jagged edges, uneven surfaces, and asymmetrical features. It's as if nature itself decided to throw the rulebook out the window when crafting this distant wanderer. What could have caused such an unusual shape? One possibility is that the cosmic puzzle is the result of a violent collision in the distant past. Imagine two smaller objects slamming into each other at incredible speeds, their icy surfaces shattering and reforming into a chaotic, fragmented mass. Over time, gravity might have pulled these pieces together, but not enough to smooth them into a sphere. Instead, the object retained its irregular form, a frozen snapshot of cosmic chaos. Another theory suggests that the cosmic puzzle could be a captured interstellar object, one that originated far beyond our solar system. If it formed in a different environment, perhaps one with weaker gravitational forces or unique chemical compositions, its irregular shape might reflect the conditions of its birthplace. This idea opens up fascinating questions about how objects form in other star systems, and whether our solar system's preference for spherical bodies is the exception rather than the rule. The cosmic puzzle also offers valuable insights into the forces that shape objects in the Oort cloud. In the inner solar system, where gravity is stronger and collisions are more frequent, objects tend to become spherical as they grow larger. But in the Oort cloud, where gravity is weaker and collisions are rare, objects might retain their irregular shapes for billions of years. This suggests that the cosmic puzzle could be a pristine relic of the early solar system, untouched by the processes that smoothed out other bodies. Studying this object could also shed light on the formation of other irregular bodies, such as asteroids and comets. By understanding the forces that shape the cosmic puzzle, scientists can better explain why some objects in our solar system are spherical while others are not. This knowledge could even help us identify similar objects in other star systems, expanding our understanding of how planetary systems evolve. But the significance of the cosmic puzzle goes beyond its shape. Its very existence challenges our assumptions about the Oort cloud as a region of uniformity and stillness. Instead, it suggests that this distant realm is a place of diversity and complexity, where objects can take on forms that defy our expectations. The cosmic puzzle is a reminder that, even in the farthest reaches of our solar system, there are still mysteries waiting to be unraveled. As we continue to explore the Oort cloud, objects like the cosmic puzzle invite us to rethink what we know about the formation and evolution of celestial bodies. They remind us that the universe is full of surprises and that even the most distant corners of space hold clues to the grand story of our solar system. The cosmic puzzle isn't just an oddity, it's a key to understanding the forces that shape the cosmos. Now, let's journey deeper into the Oort cloud to uncover one of its most enigmatic residents, the Silent Sentinel. This object stands as a frozen relic, seemingly untouched by the passage of time. Unlike many other bodies in the solar system, which bear the scars of collisions or the marks of geological activity, the Silent Sentinel appears to have remained in a state of perfect preservation for billions of years. Its pristine condition offers a rare glimpse into the early days of our solar system, acting as a cosmic time capsule that has survived the eons without significant alteration. What makes the Silent Sentinel so remarkable is its apparent immunity to the forces that typically reshape celestial bodies. In the inner solar system, planets and moons are constantly bombarded by asteroids, comets, and other debris, leaving behind craters and reshaping their surfaces. Even in the Kuiper belt, objects are subject to occasional collisions and gravitational interactions that alter their forms. But in the Oort cloud, where distances are vast and interactions are rare, objects like the Silent Sentinel can remain virtually unchanged. This suggests that the Oort cloud is not just a repository of icy debris, but also a sanctuary for some of the oldest and most pristine objects in the solar system. The Silent Sentinel's untouched state provides scientists with a unique opportunity to study the conditions of the early solar system. By analyzing its composition, researchers can gain insights into the materials that existed when the planets were still forming. Its icy surface, likely composed of ancient ices and organic compounds, could hold clues about the chemical processes that occurred billions of years ago. This information could help us piece together the story of how the solar system evolved from a swirling cloud of gas and dust into the complex system we see today. But the Silent Sentinel's significance goes beyond its scientific value. Its existence challenges our understanding of the Oort cloud as a dynamic and ever-changing region. While some objects in the Oort cloud are shaped by collisions or influenced by passing stars, others, like the Silent Sentinel, remain frozen in time. This duality suggests that the Oort cloud is a place of both activity and stillness, where some objects are shaped by external forces while others remain untouched, preserving the secrets of the past. The Silent Sentinel also raises intriguing questions about the stability of the Oort cloud over cosmic timescales. If this object has remained unchanged for billions of years, it implies that the Oort cloud has been a relatively stable environment for much of its history. This stability could be due to its immense distance from the Sun, which shields it from the gravitational disturbances that affect the inner solar system. It also suggests that the Oort cloud could serve as a long-term archive, preserving ancient objects for future generations of astronomers to study. As we continue to explore the Oort cloud, objects like the Silent Sentinel remind us of the incredible diversity and complexity of this distant region. They challenge us to rethink our assumptions about the solar system's history and the forces that have shaped it. The Silent Sentinel is more than just a frozen relic. It's a testament to the enduring mysteries of the cosmos and a reminder that even in the farthest reaches of space, there are still stories waiting to be told. As we venture even further into the depths of the Oort cloud, we arrive at the very edge of our solar system where the final frontier begins. Here, we encounter an object that stands as a silent sentinel, marking the boundary between the familiar and the unknown. This object, located at the outermost reaches of the Oort cloud, serves as a cosmic gatekeeper, guarding the transition from the Sun's gravitational influence to the vast expanse of interstellar space. What makes this object so extraordinary is its position. It lies at the farthest point where the Sun's gravity still holds sway, a place where the pull of our star weakens and the influence of other stars begins to take over. This boundary is not just a physical limit but also a symbolic one, representing the edge of humanity's current understanding of the solar system. Beyond this point, the interstellar void stretches endlessly, filled with mysteries waiting to be uncovered. The object itself is a fascinating enigma. Its composition and structure remain largely unknown, but its location suggests it could be a relic from the earliest days of the solar system. Some scientists speculate that it might be a fragment of a larger body, perhaps a planetesimal that never fully formed, or even a visitor from another star system that was captured by the Sun's gravity long ago. Whatever its origin, this object holds clues about the processes that shape not just our solar system, but also the broader galaxy. One of the most intriguing aspects of this object is its role as a sentinel. Its position makes it a natural marker for the boundary of the solar system, a point where the influence of the Sun gives way to the forces of interstellar space. Studying this object could help us better understand the transition between these two realms, shedding light on how the solar system interacts with its galactic surroundings. It could also provide insights into the nature of the interstellar medium, the sparse collection of gas and dust that fills the space between stars. But the significance of this object goes beyond its scientific value. It serves as a reminder of the vastness of the cosmos and the limits of human exploration. For now, this object lies beyond our reach, a distant beacon at the edge of the known. Yet, it also represents a challenge and an opportunity, a call to push the boundaries of our knowledge and technology. Future missions equipped with advanced propulsion systems might one day target this object, offering us a closer look at the final frontier and what lies beyond. As we reflect on this object's place in the solar system, we are reminded of the endless possibilities that await us in the cosmos. It stands as a testament to the enduring spirit of exploration, a symbol of humanity's quest to understand the universe and our place within it. The final frontier is not just a boundary, it's an invitation to dream, to discover, and to venture into the unknown. Now, let's take a closer look at what this object's location truly means for our understanding of the solar system's boundaries. Positioned at the very edge of the Sun's gravitational reach, this object acts as a natural marker, helping scientists define where our solar system ends and interstellar space begins. It's a critical point where the Sun's influence begins to wane, and the forces of the wider galaxy start to take over. This transition zone is not just a theoretical concept, it's a tangible boundary that shapes how we think about our place in the cosmos. The Sun's gravitational pull extends far beyond the planets, stretching into the Oort cloud and beyond. But as we move farther out, that pull weakens, and the gravitational influence of other stars and the Milky Way itself becomes more significant. This object, sitting at the edge of this transition, offers a unique opportunity to study how these forces interact. By observing its behavior, scientists can gain insights into the delicate balance between the Sun's gravity and the pull of the galaxy, helping us map the true limits of our solar system. But this boundary isn't just about gravity, it's also about the flow of particles and energy. The Sun emits a constant stream of charged particles known as the solar wind, which creates a protective bubble around the solar system called the heliosphere. At the edge of this bubble, the solar wind collides with the interstellar medium, the thin gas and dust that fills the space between stars. This collision creates a turbulent region known as the heliopause, and the object we're discussing likely resides near this boundary. Studying it could reveal how the solar wind interacts with the interstellar medium, shedding light on the dynamics of this cosmic frontier. What's even more fascinating is how this object's location challenges our understanding of the solar system's shape and structure. For a long time, scientists imagined the heliosphere as a smooth, comet-like structure with a defined head and tail. but recent observations suggest it might be more irregular, shaped by the pressure of the interstellar medium and the motion of the Sun through the galaxy. This object sitting at the edge could provide crucial data to refine these models, helping us visualize the true shape of our cosmic neighborhood. Beyond its scientific value, this object's location also has profound implications for future exploration. As humanity looks to the stars, understanding the boundary of the solar system is essential for planning interstellar missions. It's a reminder that even as we push the limits of our technology, there are still fundamental questions about the universe that remain unanswered. This object standing at the edge of the known beckons us to venture further, to explore not just the solar system but the vast expanse that lies beyond. In many ways, this object is more than just a scientific curiosity. It's a symbol of humanity's enduring quest to explore the unknown. It represents the edge of our current knowledge, a place where the familiar gives way to the mysterious. And as we continue to study it, we're reminded that the universe is full of wonders waiting to be discovered, each one offering new insights into the cosmos and our place within it. Now, let's turn our attention to what this object might mean for the future of space exploration. Positioned at the very edge of the solar system, this enigmatic body could serve as a gateway to the interstellar void, offering a unique vantage point for studying the space between stars. Its location makes it an ideal candidate for future missions aimed at exploring the uncharted territories beyond our cosmic neighborhood. Imagine a spacecraft venturing out to this distant object, equipped with instruments designed to analyze the interstellar medium and the forces shaping the boundary of our solar system. Such a mission could provide unprecedented insights into the conditions of interstellar space, helping us understand how our solar system interacts with the wider galaxy. The idea of using this object as a stepping stone for interstellar exploration is not just science fiction, it's a tangible goal that scientists are already considering. By studying its composition, trajectory, and environment, we could gather critical data to design missions that go even farther. For instance, understanding how the solar wind interacts with the interstellar medium at this boundary could help engineers develop spacecraft capable of withstanding the harsh conditions of deep space. This object could act as a testing ground for technologies that will one day carry us to the stars, but the significance of this object goes beyond its scientific value. It represents a bridge between the known and the unknown, a place where humanity's curiosity can take its next great leap. As we look to the stars, this object reminds us that the solar system is just the beginning. It challenges us to think bigger, to dream of missions that will carry us into the vast expanse of interstellar space. And while such missions may still be decades away, the groundwork we lay today, by studying objects like this one, will pave the way for those future journeys. In the meantime, this object continues to captivate our imagination, serving as a reminder of how much we have yet to discover. It's a symbol of the boundless potential of exploration, a beacon calling us to venture beyond the familiar and into the unknown. As we continue to study it, we're not just learning about the edge of the solar system, we're preparing for the next great chapter in humanity's journey through the cosmos. And who knows, one day this object might be remembered as the first step on our path to the stars. As we reflect on this distant object, it's impossible not to consider its deeper meaning. This isn't just a scientific curiosity, it's a symbol of humanity's unyielding desire to explore, to push beyond the boundaries of what we know. Positioned at the cosmic horizon where the solar system fades into the interstellar void, this object represents the edge of our understanding and the beginning of a new frontier. It's a reminder that, even in the vastness of space, there are still mysteries waiting to be uncovered, challenges waiting to be met, and questions waiting to be answered. From a philosophical perspective, this object embodies the essence of exploration itself. It's a testament to our curiosity, our drive to seek out the unknown, and our determination to understand our place in the universe. For centuries, humans have looked to the stars and wondered what lies beyond. This object, sitting at the very edge of our solar system, is a physical manifestation of that wonder. It's a beacon that calls us to look further, to dream bigger, and to imagine what might lie beyond the cosmic horizon. Scientifically, this object is equally significant. Its location offers a unique opportunity to study the transition from the solar system to interstellar space. By analyzing its properties and the environment around it, we can gain insights into the forces that shape the boundary of our cosmic neighborhood. This knowledge isn't just academic, it's practical. Understanding how our solar system interacts with the wider galaxy could help us design future missions that venture even farther, carrying humanity's quest for exploration into uncharted territories. But perhaps the most profound aspect of this object is what it represents for the future. It's a reminder that the solar system is just the beginning. Beyond it lies a universe filled with possibilities, new worlds, new discoveries, and new challenges. This object, standing at the edge of our cosmic backyard, is a stepping stone to that future. It's a symbol of hope, a reminder that no matter how far we've come, there's always more to explore. As we continue to study this enigmatic body, we're not just learning about the edge of the solar system, we're preparing for the next great leap in our journey through the cosmos. It's a journey that will take us beyond the familiar, beyond the known, and into the vast expanse of interstellar space. And as we look to the cosmic horizon, we're reminded that the greatest adventures are still ahead. This object, sitting at the boundary of our solar system, is a promise of what's to come, a promise that the universe is waiting, and humanity is ready to answer the call. As we bring our journey through the Oort cloud and beyond to a close, it's worth taking a moment to reflect on the incredible diversity and mystery of the objects we've explored. From the first visitor believed to originate from this distant region to the enigmatic sentinel marking the edge of our solar system, each of these 25 strange objects has offered us a glimpse into the vast, uncharted territories that lie at the fringes of our cosmic neighborhood. Together, they paint a picture of a solar system that is far more complex, dynamic, and mysterious than we ever imagined. These objects are more than just curiosities, they are keys to unlocking the secrets of our solar system's formation and evolution. They challenge our assumptions, push the boundaries of our knowledge, and inspire us to ask new questions about the universe we inhabit. Whether it's the icy fragments of ancient planets, the dark wanderers cloaked in mystery, or the interstellar visitors hinting at the vastness of the galaxy beyond, each discovery brings us closer to understanding the intricate tapestry of our cosmic home. But the story doesn't end here. The Oort cloud and the objects within it are just the beginning. They remind us that there is still so much to explore, so many questions waiting to be answered, and so many mysteries waiting to be uncovered. As we continue to study these distant realms, we're not just learning about the past, we're preparing for the future. A future where humanity ventures beyond the boundaries of our solar system, into the vast expanse of interstellar space and perhaps even beyond. So, what do you think about these strange and fascinating objects? Which one captured your imagination the most? Let us know in the comments below. We'd love to hear your thoughts and theories. And if you enjoyed this journey through the mysteries of the Oort cloud, don't forget to hit the like button, subscribe to our channel, and ring the notification bell so you never miss out on our next cosmic adventure. The universe is full of wonders and we're just getting started. Thanks for watching and we'll see you in the next video.